In this video, I'm going to talk about how we can draft quadratic functions. Now, as we discussed earlier, quadratic function will take the form ax squared plus bx plus c. So, in this example, I'm considering the function y equals x squared. Now, in this function, we have our ax squared term and we assume that a isn't equal to 0. Therefore, we will take values for x and evaluate what we can get for y. If x is minus 2, value of y is 4. Minus 2 squared is 4. If x is minus 1, value of y is 1. If x is 0, value of y is also 0. This function will go through the origin. If x is 1, value of y is 1. Because 1 squared is 1. If x is 2, value of y is 4. Let's plot our graph on this Cartesian plane. When x is minus 2, y is 4. When x is minus 1, y is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. So we can draw our graph like this. Now, this is the function of y equals x squared. Now, there are some properties related to these type of functions. As you can see, this graph is symmetrical about the y-axis. This is our y-axis and this is our x-axis. So, this graph is symmetrical about the y-axis. When x increases from minus 3 to 0, the value of y decreases. When x increases from 0 to plus 3, the value of y increases. And our minimum point is 0. The minimum point, the coordinates of the minimum points are 0, 0. So a function that takes the form y equals x squared, when a doesn't equal to 0, will have a minimum point, and the minimum point will be the origin. Let's consider another example. Now I consider the function y equals minus x squared, where a is less than 0. Now let's see what changes we can see when we plot it on a Cartesian plane. Let's take some values for x and evaluate what we get for y. When x is minus 2, y is minus 4, because equals minus 2 into this function. Minus 2 squared is 4. 4 multiplied by minus 1 is minus 4. Minus x squared means minus 1 multiplied by x squared. When we substitute minus 1, we get minus 1. When we substitute 0, we get 0. Like in the case of previous function, this function also goes through the origin. Then if we substitute 1, we'll get 1 squared is 1. 1 multiplied by minus 1 is minus 1. 2 is, when we substitute 2, we get minus 4. Let's draw the graph. When x is minus 2, y is minus 4. When x is minus 1, y is minus 1. When x is 0, y is 0. When x is 1, y is minus 1. When x is 2, y is minus 4. Therefore, we can draw our graph like this. Now, this is y equals minus x squared. Now, this function has a maximum point. This function has a maximum point and the coordinates of the maximum points are 0 and 0. When x is 0, y is 0. It is the origin. And it is symmetrical about the y-axis. When x value increases from the minus side, the corresponding y value decreases. When x value increases, y value decreases. So those are some of the properties related to y equals minus x squared function. We see when the coefficient of x is positive, we get a minimum point, like in the case of y equals x squared function. But when the coefficient of x is negative, we get a maximum point, and the coordinates of the minimum and maximum points are 0 and 0. Let's consider another aspect related to quadratic function. Okay, now I consider the following function. Y equals ax squared plus b, where a less than or equal to 0. Now consider this as an example, x squared plus 3. Now as we discussed earlier, these type of function should have a minimum because x value is positive. Let's substitute x equals 0 and evaluate the value of y. When x equals 0, value for y is 3 because 0 squared is 0, 0 plus 3 is 3. That means this function will go through point 3 and it will have a minimum point there. Similarly, y equals x squared plus 1 will go through point 1, and when x equals 0, value of y is 1, and that is its minimum point. Now this property is known as the vertical displacement of functions of this nature. That is, if function is of the type y equals a squared plus b, it can be vertically displaced by changing the b term. Now in this case, I also consider the same function, y equals x squared plus b, but this time a is less than 0. So my function is y equals minus x squared minus 1. Now in this case, when x equals 0, value of y is minus 1. That means our function will pass through minus 1. Let's consider this function. Y equals minus x squared minus 3. In this case, when x is 0, y is minus 3. So the maximum point will vary depending on the value that b takes. So this vertical displacement of the function is applicable irrespective of whether the function has a maximum point or a minimum point. Okay, let's consider another example where we can find the value of x without using factorization or any other method, just by using the graph itself. Consider this function y equals x squared minus 4. Let's substitute values for x and obtain our values for y. When x is minus 3, value of y is minus 3 squared is 9, 9 minus 4 is 5. When x is minus 2 squared is 4, 4 minus 4 is 0. When x is minus 1, minus x squared is 1, 1 minus 4 is minus 3. When x is 0, 0 squared is 0, 0 minus 4 is minus 4. When x is 1, 1 squared minus 4 is minus 3. When x is 2, y is 0. When x is 3, y is 5. Let's plot our points and draw the graph. When x is minus 3, y is 5. We are here. When x is minus 2, y is 0. When x is minus 1, y is minus 3. When x is 0, y is 4. When x is 1, y is minus 3. When x is 2, y is 0. When x is 3, y is 5. Therefore, we can draw our graph like this. Now, this is our y equals x squared minus 4. Now, as per the information, our minimum point is minus 4. When x equals 0, y is minus 4. And the solutions for the functions are given by the points where the graph cuts the x-axis. That is, when y is 0, what is the value of x? Now from our previous knowledge, we know that if y is 0, x squared minus 4 will give us, that is x squared minus 2 squared, x minus 2 into x plus 2 equals to 0. Therefore, x minus 2 equals to 0 or x plus 2 equals to 0. Therefore, x equals plus 2 or x equals minus 2. But by looking at our graph, we can clearly see that when y value is 0, x is minus 2 or x is plus 2. Therefore, we can come to the conclusion that whenever a parabola graph, these kind of graphs are known as parabola graph. When a parabola graph cuts the x-axis when y is 0, it will give us the answers for the function. Algebraically also, we can see that our answers are x equals minus 2 or x equals plus 2. Now that's about how to plot basic quadratic functions on a graph and obtain answers. Do subscribe our channel and hit the like button. Leave your comment in the comment section. Thank you for watching. Have a great day.